All right, so continuing on with composition functions, let's look at the next example. So the altitude of a small airplane t hours after taking off is given by a of t is negative 2.8 t squared plus 6 thousand feet, where t is between 0 and 2. The air temperature in the area at an altitude of x thousand feet is f of x equals 68 minus 3.5 x degrees Fahrenheit. So what does this composition measure? So so really we just need to figure out what is the input. The input is time, and that's hours after takeoff. And then what is F measuring? F is measuring the temperature in degrees Fahrenheit. So what this H of T is measuring is H of T is measuring temperature after T hours. Okay. So let's find H of 1. So H of 1 is F of A of 1, and like we did in the last video, we need to find A of 1. So we're going to plug 1 into this one right here. So negative 2.8 times 1 squared plus 6.7 times 1. And so that would give us 3.9. 3.9 what? A of T is measuring altitude, thousands of feet. So 3.9 or 3,900 feet. So now we're going to plug this into F. So we need F of 3.9. And so we're going to plug that one in to X. So 68 minus 3.5 times 3.9. And we get 54.35. So after 1 hour, so the one here is measuring hours. So after 1 hour, the temperature is 54.35. And I don't have room to write that, so we'll just say it. Interpret the results. After 1 hour, the temperature is 54.35 degrees Fahrenheit. All right, so let's find a formula for this. So H of T. So H of T is F of A of T. So we're going to plug the A of T in to F. So where we have an X here, we're going to plug this function in. So we have 68 minus 3.5 and then plug in the A of T. So negative 2.8 T squared plus 6.7 T. So we have 68, and let's distribute the negative 3.5, and we get 9.8 plus 9.8 T squared, and then negative 3.5 times 6.7, we get minus 23.45 T. And we can just leave it like that. We don't need to rearrange it. You can if you want. But that is our H of T. So we get whatever time we have, we can plug that into the formula and we can figure out the temperature after that many hours. All right, so let's see what we have next. All right, so this example, we're given a composite function. L of T is a composite function. It is composed of F and G, and we need to figure out what F and G are. So this one, you can kind of, and of course these could get pretty complicated, but I think in this class they're going to stay fairly basic. And I would say probably start in the middle, and that will be your input function. So the input will be the middle part. So G of T is 2T minus 1. And then F of T is the outer part. So in this case, t cubed. And you could figure this out. Like if we wanted to figure out from these two, what is f of g of t, just kind of check. Well, we plug this into that, and we get exactly what we would hope to get. So, so there's our g of t, and there's our f of t. So just kind of start in the middle. That's your input function, whatever that one is. In this case, input function is g, and that's the part in the middle of the parentheses. And then the outer part is your f, and probably you'll just put in your x or your t, whatever the variable is, and then to whatever the outer function is in your composite function there. All right, so we saw one way to evaluate these in the earlier example, where you just plug it into the input function and then plug that number into the output function. But we can also use graphs. We'll use tables here in a minute. So we have the graph of f here. We have the graph of g. And so let's find f of g of 5. So g of 5 we need. And so g of 5 would be 1. So f of g of 5 is f of 1, and then f of 1 is 0. All right. Let's try g of f of 0. What is f of 0? F of 0 would be -1. Now g of -1 is, so there's -1, g of -1 is 4. I guess we could have written g of f of 0 equals g of -1, but that's okay. All right, f of g of 0. So now we need g of 0. So g of 0 is 2. So f of g of 0 is f of 2. So what is f of 2? F of 2 is 1. And then last one, f of 4. So now this time we're just going to stay on f. So f of 4, so we're finding that part first. F of 4 is 3. So then f of 4 is the same as f of 3, because f of 4 equals 3 right there. So what is f of 3? F of 3 is 2. There you go. So works the same way, but just have a graph instead of the equation. Then we can also use a table. Oops. So with the table, kind of do the same way. So we need f of g of 3. So let's find g of 3 first. So g of 3, here's our x row. So there's 3. So then g of 3 would be 2. And so then this is f of 2. F of 2 would be 8. And then we'll do the same thing but reversed. So g of f of 3, so we need to find f of 3. So f of 3 would be 3. So g of f of 3 is g of 3, and g of 3 is 2. Okay, so I think those are all the different types of problems that you'll see using the composition, but the idea is always the same. This number here goes into the function next to it, and then you get an answer, and then you plug that number into the outer function, and that's how you do the composition. All right, so the next one we'll start with the transformations.